Hi guys, we're going to have a quick look at factorising quadratics today when they either have 2 or 4 terms. So these are not the quadratic trinomials that we dealt with in the last session. They're quite simple to deal with if you just have a few little clues as to how you might handle them. And there are 2 possible ways that you can look at them very quickly, and if they don't work, there's another one up my sleeve to show you, okay? So yes, there are 2 possible approaches which can be used, but firstly, always, guys, always look for the common factor and take out any common factors, because that makes things much, much easier if you do that, always, okay? Yes, it does. Okay, the 2 techniques to try I'd like you to consider are, first of all, the difference of 2 squares. If the expression contains 2 terms, and particularly if they are squared terms, okay? Now you'll see that in a moment, how easy it is. And the second technique is grouping 2 by 2 if the expression contains 4 terms. Now that usually works, but sometimes it might not work in that case, that's where I have the other little trick up my sleeve, which I will show you. Oh, right, now, what have we got here? Factorise each of the following. Now, have a look at these guys. You'll see that that is something squared, and we can turn that into something squared even if it isn't a perfect square. It is a perfect square in that case, but this one down here isn't. But we can turn that into the square root of 17 squared. And just leave it as a surd like that. I'll show you in a moment, okay? Let's not get ahead of myself. Part A, 4x squared minus 9, okay? Now, that contains 2 terms, both of which we can make into squares. So that is, and one is being taken away from the other. So it is a difference of 2 squares, you see? There you go. So it's 2x all squared minus 3 all squared. Now you know, if you have a quadratic expression which says a squared minus b squared, for example, well, that factorises to a plus b times a minus b, okay? And that's what we do in this case. The a would be the 2x and the b would be the 3, so we get 2x minus 3 times 2x plus 3, or 2x plus 3 times 2x minus 3. It makes no difference the order in which they occur. So that gets a box. Thank you, Mr. Box, for that. Okay, very easy, isn't it? You see? Here's another one, just to get going while we're on a roll here now. What did I say up here, guys? Look, see? Look at my little froggy green finger. Look. Firstly, look for and take out any common factors. So, you see, this looks a little bit awkward, so I immediately go into, common factor mode. Can I take out a common factor? And in fact, you can. Okay, you can take out 7 out of both of those terms, and what happens is you get 7 into x squared minus 64. Okay, now it's much easier to deal with what's inside this bracket, you see. So you can call that x squared minus 64. It certainly is a difference of 2 squares, and it's x all squared minus 8 all squared, and you know the rest of the story, don't you? That's it, okay? A very happy ending indeed. Let's look at number C now. X squared minus 17. Well, this is a case where you shoehorn it into a difference of 2 squares. We know that 17 is not a perfect square. There's no common factors anywhere, but we can call 17 something squared, okay? We can call it the square root of 17 squared, because the square root of 17 squared gets us 17. There it is, guys. So it's just x minus root 17 times x plus root 17, and we've got the answer. And thank you, Mr. Box. Okay, so this is the difference of 2 squares approach. Remember, this you try this if you have 2 terms and you can make them into squares, and one is taken away from the other. Okay, there has to be a minus in between the 2 terms, otherwise it doesn't work. Okay, let's have a look at this. Now, the first thing that you can see when you look at these is that there are 4 terms. So you immediately get your antenna up and think, well, this is not a quadratic trinomial. It's certainly not a difference of 2 squares. Maybe I could try grouping 2 and 2. Okay, and let's see what happens when we do that. Here's number A. Alright, now if I just group the first two terms and the second two terms and I take out any common factors, you have a look. Okay, now have a look. There's really nothing to take out of the first two terms, is there? But what about the second two terms? Can you see that M is in both of those? Well, let's proceed on that basis and see what we get. Oh, excellent. Now we can see that this bracketed term here and here, they're in common. They are in common to this term, aka just itself, and this term here. Okay? Now there's really a little silent 1 in front of that bracket there. So what we can do is we can take out, or we can express it like that, just to make it clear what we're doing here. And I've written in red there for you what's there in addition to the common factors, yes? So let's take out the common factor and see what we get. There it is, okay? There it is, and we factorise it into linear factors, okay? And that's the answer. Excellent. Right, now let's have a look at B now and see if we can do the same thing. Well, just glancing at it, it looks very suspiciously like we can. Now you have a look. What about the first two terms in B? And what about the second two terms in B? Can you see a common factor in each of those two groups of terms? Well, I certainly can. The first two terms I can see an X, and in the second two terms I can see a Y. Okay? However, that's not the way we're going to do it. Because if we proceed along that path, we're going to get like a false result, which really doesn't go anywhere. Because if you took an X out of here, you would see that it'd be X into X plus 3, and then if you took a minus Y out of here, you would get minus Y into Y minus 3. So X plus 3, Y minus 3, oh dear, that's not getting us anywhere. Okay? So you think about something else. If you rewrite this, you will get x squared minus y squared plus 3x plus 3y. Now, look at this. Difference of two squares, yes. So that'll be x minus y times x plus y. And you can take 3 out of here so that you get 3 into x plus y. And there'll be a common term of x plus y to take out. You see? Now you think, what will the next line be if we took out x plus y as a common factor out of this term here and this term here? Okay? Exactly. You would get x minus y from here, that's all that's left over, and you would get plus 3 from here, that's all that's left over from that term. So there is your answer. That is your answer. That's a perfectly valid factorised answer from this original expression. Okay? Last but not least, let's have a look at this one. This has 4 terms in it, so therefore we consider grouping 2 by 2. But alas, it's not going to work, and I'll show you if you think about that. What could we do with it? We could say we could take x out of here and get x plus 12, and then what would we take out of there? It really wouldn't work very well, would it? What about if we took x squared minus y squared as a difference of two squares? Then we'd get x minus y, x plus y, but then, you know, that really doesn't help us, because if you take the 12 out of these two terms grouped together, you'll get 12 into x plus 3, so that's no good either. So this one's a particularly difficult one for us to work out what to do. But there is a third possibility when the grouping doesn't work, which I was alluding to at the start of this little session, and that is, keep your radar well and truly tuned into what might be possible, guys. And if you do a lot of practice of these things, you'll get an eye for them. Only if you do a lot of practice will you get an eye for them. And I can see that the 3 terms here, the x squared plus 12x plus 36, that is in fact a perfect square. That is a perfect square. Are you aware that that's a perfect square? Well, it is. So there. So let me show you the rabbit out of the hat that I can pull on this one. This is a case where grouping 2 by 2 doesn't work to produce linear factors, as we've just discovered, much to our disgust. and therefore an alternative approach is required, okay? So notice that, yes, the first three terms are a quadratic trinomial and that they are a perfect square. So therefore, we can use the following approach. Okay, we've got that. Now, let's just factorise the first three terms as a quadratic trinomial, in fact, as a perfect square, and you get that. Now, can you see that? Look, you've got something squared, even though it's x plus 6 in brackets all squared, it's still something squared, minus something else squared. So, therefore, we can factorise that now as a difference of two squares, you see, because you've got a minus sign here in the middle. That's all you need, okay? So it's going to become the first thing, yes, it's going to become the first thing minus the second thing times the first thing plus the second thing, and I've put it in big square brackets so as not to confuse everybody with brackets everywhere. And now we can just simplify this and get rid of these round brackets in here to produce the next line as shown. Okay, we've just got x plus 6 without brackets minus y, x plus 6 without brackets plus y, and we just express it like that. Okay? And that is the answer, guys. That is the answer. So that is the third technique which you can try if all else fails, okay? Yes, and here's the remember for you. Why don't you just pause the video and have a look at that and digest it, and you'll benefit from that as well. And that's the end of my little session today. So I hope you got plenty out of that, and I want you to go away and do plenty of practice, because as I said to you, you only get good at these if you do plenty of practice and you develop an eye for them, okay? Alright, well, you have a wonderful day and all the best to you.